Hello, this is Professor Megan Bunnell, and I saw that you had questioned your Unit 7 check-in assignment regarding question 9 in your Unit 7 homework. So I wanted to create a short video on how to solve this problem. This problem gives us a system of equations, and we're asked to solve it by using the addition method. Now here we have 2x squared minus 4y squared equals negative 8, and then the second equation is 5x squared plus 3y squared equals 32. The addition method means that we're going to add these two equations together in order to eliminate a variable. If we add the equations together as is, we won't be eliminating any variables. So I need to multiply my equations by certain factors so that when I add it together, one of the variables go away. So if I look at the x term, I'm going to choose to get rid of the x squared term. So I need to multiply both of these by a factor. And if I look at this, if I multiply the 2x squared by a positive 5, I'll get a positive 10x squared. If I multiply the second equation by a negative 2, I'll get a negative 10x squared. So as you can see, by doing that, I'll get a 10x squared and a negative 10x squared, and when I add those two things together, it will eliminate the x squared variable. So I'm going to choose to multiply the top equation by 5 and the bottom equation by negative 2. Okay, so if I look at the top equation, I have 5 times 2x squared, which gave me the 10x squared, and now I'm going to multiply 5 by a negative 4y squared, and that gives me a negative 20y squared. Next, I'll multiply the 5 times the negative 8, and that gives me a negative 40. Now we'll look at the bottom equation. A negative 2 times 5x squared is a negative 10x squared. A negative 2 times a positive 3y squared is a negative 6y squared. And a negative 2 times a positive 32 is a negative 64. Now that I have my new equations, I'm going to add each like term together. And as you can see, the positive 10x squared and the negative 10x squared zero out and go away. Now I'm going to add the negative 20y squared to the negative 6y squared. So two negatives when added together gives me a larger negative number. So this becomes a negative 26y squared. And that equals a negative 40 plus a negative 64, which is a negative 104. Now I'm simply going to solve for y squared. So I need to isolate my variable. To do that, you do the opposite operation. So you'll divide both sides by a negative 26. And you have y squared equals negative 104 divided by negative 26. And that will give you a positive 4 because a negative divided by a negative is a positive. Now I have y squared equals 4. So I'll take the square root of y squared, so that gives me a single y. And whenever you take the square root, we want to do plus or minus beside it. So this becomes plus or minus the square root of 4, which is 2. And that means that y equals a positive 2 and y equals a negative 2. Now that we've found that y can equal negative 2 and y equals 2, we're going to plug those values into just one equation, one at a time, and solve for x. So I can choose either equation to plug in my values that I know for y. So y equals negative 2, and it also equals a positive 2. So I'm just going to choose the top equation, and I'm going to plug y in to that equation. So I have 2x squared minus 4 times negative 2 squared equals negative 8. I'm going to solve for x. First, you apply the exponent on the negative 2, so a negative 2 squared is a positive 4. Now you're going to multiply the 4's together, and negative 4 times positive 4 is negative 16 or minus 16. So I have 2x squared minus 16 equals negative 8. We'll add 16 to both sides, and we get 2x squared equals positive 8. A negative 8 plus 16 is a positive 8. And then you divide by 2, and we get x squared equals 4. So take the square root of 4, and that's a negative 2 or a positive 2. So x can equal negative 2, and x equals positive 2. So that means that when y is negative 2, we have two different values for x. So that means we have two different ordered pairs. The first ordered pair is negative 2, negative 2. The second ordered pair is 2, negative 2. Now I'm going to do the same thing with y equals 2, and I'm going to plug that into the top equation again. So I have 2x squared minus 4y squared equals negative 8. We get 2x squared minus 4 times 2 squared equals negative 8. 2 squared is 4. We'll multiply 4 times 4 together. We get a minus 16. And then add 16 to both sides. We get negative 8 plus 16 is a positive 8. And that equals 2x squared. So again, we'll divide both sides by 2, and we get x squared equals 4. And that means that just x, when I take the square root, x equals negative 2 and x equals a positive 2. So again, when y equals 2, I have two solutions for x. So my first ordered pair is negative 2, 2. My second ordered pair is positive 2, 2. And these are my four solutions, or four ordered pairs. So the solution set for that system of equations is 2, 2, 2, negative 2, negative 2, 2, and negative 2, negative 2. So you have four ordered pairs for that solution. Okay, I hope that helped. Please shoot me an email if you have any questions. Thank you.